Magnatele sucatelo stu limone,
Okay, believe it or not, we're still talking about ionic compounds. This is probably the third video where we're talking about it. In this video, we are going to talk about something called a polyatomic ion and how polyatomic ions can also make ionic compounds. So I want to break the word polyatomic apart for you so that it's maybe a little less mysterious. Poly, the prefix poly means many. Atomic means related to atoms. And ion, you should probably know what that means. That's an atom or a group of atoms that has an electrical charge. Polyatomic ion just means the group of atoms that has an electrical charge. So, a group of atoms with an electrical charge. This little bit about polyatomic ions, it's sometimes confusing to students, so I'm going to try to go through it somewhat slowly, and hopefully it will make sense. Don't memorize this word, polyatomic ion. It's not really necessary to know. You should just understand the idea of what I'm about to show you on the next slide. So this is a table with a bunch of formulas and a bunch of names associated with those formulas. Every formula on the left is a representation of a polyatomic ion. But here's where you might be confused if you were a beginning student, like I would have been confused. You see this negative sign here, so you think, well, okay, this hydrogen has a charge of -1. That's supposed to be a 1 minus, because there's a minus sign next to it in the upper right. However, that's not quite right. What's happening actually is that the O and the H here travel as a pack. And the entire pack, the whole thing that I'm circling, 1 oxygen and 1 hydrogen, the whole thing has a charge of -1. It's not just the hydrogen that's charged at -1. You have to realize that these things travel as a group and think of them as inseparable under those conditions. This O and this H with a -1 charge has a fancy name. It's called a hydroxide ion. You don't need to know that either. But I'm just sort of telling you so you understand how to read this table. This is 1 carbon and 1 nitrogen. Again, if you didn't know any better, you might think that it's the nitrogen that has a charge of -1, but it's not. It's the carbon and the nitrogen together as a little pack. They have a charge of -1, and this little pack with the charge of -1 has a name. It's called a cyanide ion. Again, don't memorize that, but it's just a name, and you should be able to read a table like this. This is a more complicated polyatomic ion. It has 1 nitrogen, and 4 hydrogens, all bundled up together. And the entire pack, that's 5 atoms total, 1 nitrogen, 4 hydrogens, that whole pack has a little bit of an electrical charge, a charge of 1 plus. This is just another example of a polyatomic ion. It has a fancy name. It's called an ammonium ion. But you should understand what I'm trying to tell you here. It's not just the last element, it's not just the last atom that has the electrical charge. All of these things in this table, the atoms are kind of bundled together as a little gang or a little group, and the entire bundle comes with a charge. And because it's a bunch of atoms stuck to each other, it's called a polyatomic ion. Many atoms making up the ion. And they can get really elaborate. This one's called an acetate ion. It's got 2 carbons, 3 hydrogens, 2 oxygens. All those atoms, and it still only has a charge of -1. So you can have polyatomic ions that have positive charges, negative charges, -2 charge, pretty much anything you can think of. There's probably a polyatomic ion out there with that electrical charge. So I want you to be able to look at a table like this and understand, if I tell you that these are polyatomic ions, you should understand that these atoms travel as a pack and they have an electrical charge associated with that pack. Now that we have that information, I can start asking you questions that are similar to the ones in the previous videos. Suppose I told you that I had some material called calcium carbonate, and I wanted to know the formula for calcium carbonate. Well, you would remember that calcium is in the second column of the periodic table, which means it's in group 2, and the atoms in group 2 have an electrical charge of +2, and you would get a table like this. If I asked you this question, I would show you a table like this. you'd have to look up carbonate in the table. You'd say, okay, here's carbonate. There's the formula for carbonate. It's 1 carbon and 3 oxygens, and that whole thing has a charge of -2. So you'd say, okay, I've got this CO3 thing. They travel as a group, and the entire group has 2 minuses. So I want to know what the formula is. How many of these, how many calciums, have to merge with how many carbonates? And remember, the rule from the previous videos is that the ions connect to each other so that they cancel out each other's charge completely. So if I have 1 calcium with a charge of +2, and I merge it with 1 carbonate with a charge of -2, do they completely cancel each other's charge out? And the answer is yes, because this is +2, this is -2. Those things cancel out to give you a charge of 0. So I only need 1 calcium, and I only need 1 carbonate to connect to each other, to cancel each other out. Therefore, the formula for calcium carbonate is calcium 1, but nobody would write the 1, so we'll erase it, and carbonate, CO3. And there's only one of these as well, so you just leave it at that. This is the formula for calcium carbonate. And we just figured it out by using the rules about how ions stick together that we talked about in the previous videos, and using this table, which showed us the formula for carbonate and the electrical charge for carbonate. And that's it. That's pretty much all you need to do. I'll show you a more complicated example, but the principle is always going to be the same. Next question is, what's the formula for magnesium nitrate? If you remember, and you can look this up in the periodic table, magnesium is also in the second column, which means it's in group 2, which means that it has magnesium ion has an electrical charge of +2. Nitrate, probably not on everybody's on the tip of everybody's tongue, but here it is. There's nitrate. It's 1 nitrogen and 3 oxygens, and the thing has a charge of -1. So there's our NO3. That's called a nitrate, and the entire pack has a charge of -1. So you have to ask yourself, how many of each thing, how many magnesiums do I need, how many nitrates do I need to cancel each other's charge out? And you can't break these guys apart. You can't break the nitrogen and the oxygens apart. I'm telling you that it's nitrate, and because of that, you're stuck with this little formula. You can't split them apart. They have to come in these groups. So this nitrate has a charge of -1. The magnesium has a charge of +2. So hopefully you can see that I need 2 of those guys to cancel out 1 magnesium, because if I have 2 nitrates, each one gives me a charge of -1. That gives me a total negative charge of -2, and 1 magnesium has 2 positives. So I need 2 positives being canceled out by 2 negatives. And because of that, if I need 1 magnesium, the formula for magnesium nitrate is going to be Mg. I could put a 1 there, but I'm not gonna, because I don't have to. And there's 2 nitrates, so I'm going to write it like this for the moment. NO3, NO3. And that's perfectly acceptable, although nobody, it's considered a little amateurish. I don't care. You could write it that way. I'm going to show you the way that you're going to see it, though. People usually don't write this twice because they think it's tedious. What they do is they do this instead. They write Mg, there's only 1 Mg, NO3. They put parentheses around the NO3, and then they put a 2 outside of the parentheses. This 2 means 2 sets of whatever is inside of the parentheses. So this is the more common way of writing the formula for magnesium nitrate. You say there's 1 Mg, there's 2 packs of NO3s stuck to it, but I don't want to write the formula NO3 twice, so I'm going to save myself a little bit of time and write parentheses around it and write a 2. So you should understand what that means, because this is how you're going to see formulas written when you have complicated ionic compounds. Now, you can ask a different question, and you may be asking yourself this question, and you might say, well, I don't want to write it this way either. Why don't I simplify everything and say, well, I have 1 magnesium, and I have 2 nitrogens, right? There's 1, there's 2. So why don't I write Mg, N2, and here's 3 oxygens, here's another 3 oxygens, that's a total of 6. So why don't I just say the formula is MgN2O6? You can do that as well. That's also acceptable. It's usually not done either, however. The reason it's not done is because writing it this way, with the, let me clear it up, MgNO3, parentheses 2. Writing this tells trained chemists that the NO3s are traveling as a pack. that they come, and I have two sets of them. If I write the formula this way, it doesn't tell me who's traveling as a pack and who isn't traveling as a pack. So the idea is, this not only is this a little more compact, a little easier to write than this thing up here, it also tells me a little bit more information. And if I can pack more information into a formula, usually people want that information. So this is the way you're going to see it. This is okay, but it contains less information about who's traveling as a pack, how many packs you have, that sort of thing. So you won't typically see formulas that way if you have polyatomic ions. So keep that in mind. All right, we are done at least introducing ionic compounds. We've spent an awful lot of time about talking about it. Ionic bonds, that's sort of connecting atoms to each other because of opposite electrical charges. That's only one way of sticking atoms together. There are many others. We are going to talk about two others coming up. The most common other way of doing this, of sticking atoms together, is something called covalent bonding, which we will talk about in the next bunch of videos. But basically, there are ionic bonds, which we've been talking about, atoms with charges sticking together because of opposite charges. Those are typically strong bonds. They're hard to break apart. We're going to talk about covalent bonds in the next bunch of videos. There are other types of bonds as well. We're going to talk about one other type and leave it at that. But usually the first three, ionic bonds, covalent ones, and the one that I haven't introduced yet, are the most common ones that are discussed in beginning chemistry classes. So that's what we're going to talk about. So I will see you on the next video or something like that.
In a line, one stood looking at another man's wife. Then there were